Hello and welcome to our session called The Rise of the Systems Actuary, Bringing Systems Thinking to Actuarial Modeling. My name is Pamela Helig. I'm head of a consultancy called Insight Life Solutions, presenting with my colleague Garrett Nevoet, who is our head of actuarial systems at Insight. He also fancies himself a systems actuary, so he has some formal IT training, which has allowed us to present insights on this topic. So we do work in South Africa and around the world. And why we're interested in this concept of a systems actuary is because as consultants in the life insurance space, we see many actuarial systems that have been built by actuaries, but that don't necessarily follow IT or systems design principles and best practice. So our thinking with this presentation is to introduce and give credence to the concept of a systems actuary, because we believe that actuarial systems should be a science rather than something that we can intuit based on our actuarial training alone. So we believe that the systems actuary isn't just a new job title or a passing fad. It reflects a fundamental shift in how actuarial work can be done, from spreadsheets and siloed models towards integrated systems that are efficient, reliable, and sustainable. So we'll be covering why we need to develop this systems actuary mindset, what a systems actuary is, and then Garrett, as our local or as our bona fide systems actuary, will take us through some principles of good actuarial system design and cash flow model selection and where to go from here. So before we get into the presentation, we'll just show the antitrust slide and also give thanks to our sponsors. So thank you to all the sponsors that have made this event possible and given us the opportunity to be with you today. So if we think about the need for this concept of a systems actuary, we think it derives from what we've deemed a problem solver's paradox. So the paradox lies in an actuary's greatest strength, which can also be our weakness at times. So what we as actuaries excel at is being problem solvers. Put a cash flow model in front of an actuary, and given enough time, they'll be able to figure out how to operate it, how to update it, how to produce the output, and then how to tweak it to give the results they want. And that's because we've been trained to do things ourselves from first principles, not to wait for an IT person or a formal model change process to get the job done. We often have tight deadlines and we need to be self-reliant, and that's become one of our greatest strengths, in that we can run and modify cash flow models based on on the job training and intuitive actuarial thinking most of the time. And this also enables us in a tight squeeze to find workable solutions. The paradox comes in is that these solutions may not be the best, most robust, or most efficient solutions. And this is because systems thinking and what makes an excellent system and an efficient system and one that runs well isn't necessarily intuitive based on traditional actuarial training. You actually need to have studied IT or studied some kind of computer science to really understand best practice in this area. And actuaries may be good at coding in our cash flow models in various actuarial platforms, but that isn't the same as systems expertise. There's still that gap between the actuaries and the IT systems thinking. Hence the need for a systems actuary. So we're not sure what the official definition is, but we asked Google, and what Google AI came up with is a systems actuary is an actuary who focuses on the development, maintenance, and optimization of actuarial models and systems, ensuring accuracy and reliability, whilst providing technical support and collaborating with IT professionals. So a true systems actuary bridges the gap between actuarial science and IT, combining actuarial knowledge with formal systems training and systems thinking. So there needs to be some kind of formal training and expertise involved. And what's valuable about the systems actuary is that it's more than just the technical skills they bring. It's also the people and communication skills to enable us to bridge that gap between the actuarial team and the IT team, which has often been lacking in traditional insurance companies and the way they work. So we are seeing now a need for the systems actuary? And there are a few reasons that we've identified for this. Why now and why not? And why we could get away with not having formal systems thinking and training in previous years. Firstly, we are seeing many insurers embarking on major systems changes and reevaluating their traditional actuarial platforms. We conduct an industry benchmarking exercise every year, and for the last year or two, a large majority of our respondents have indicated that they are foreseeing major systems changes in the next 5 years. And this might at least partly be due to the advent of IFRS 17, which in many countries around the world really exposed inefficiencies and outdatedness of actuarial systems, because this new accounting standard requires a lot more efficiency and a lot more data handling and disclosures than previous regimes did. And that has sort of exposed the weaknesses of these legacy systems. Thirdly, around the world, across the industry, budget pressures are forcing teams to do more with less. So this makes efficiency and automation in actuarial systems non-negotiable for many teams. And finally, at least in the new generation of actuaries and even just in actuarial zeitgeist and thinking in general, there is a growing awareness of modern software solutions that offer flexibility, better integration, and scalability. What we're seeing is that many young actuaries coming into the profession leave university with a very sort of advanced knowledge of various modern softwares, and they may not be as patient with legacy systems as previous generations were. So given that background into why we have this need for a systems actuary, what a systems actuary is, and why now rather than before we find ourselves requiring this expertise, I'm going to hand over to Garrett to talk about what are some of the features of an excellent actuarial system.
Thanks. I'm just going to take control. Okay, yeah, thank you. So, yeah, I'm going to speak just a little bit about what some features of good systems, and dig a little bit more into like specific areas of systems and features we think are desirable, and try to give our little 2 cents and advice on what we think is good and bad. Maybe to start, just to say what I think is a system in the context of actuarial, and specifically being a life actuary. It's your end-to-end from receiving data, so that'll be raw from an admin system, all the way through to producing an output, and submitting that output in the form of an actuarial results report. And in between there's data cleaning and checking and auditing, and then there's your various projection runs and models that need to get done, investigations, ad hoc and standard, and outputting that result in a standardized format. And whatever layer sits on top of that orchestrates it if you have that. So the system being all those many moving parts that play with each other, that is usually spread over multiple softwares and environments and used by multiple different people in the process. And so systems, all the systems thinking really speaks to the ability to see forwards and backwards in that system and how each piece plays with each other and affects each other. So maybe just a little start just to talk about like some of these maybe obvious and less obvious costs of imperfect systems, where good systems thinking hasn't been employed. So the very easy ones are the operational impact. So just the time taken to deal with models. So here we said like model crashes, and that's I guess your worst case of a badly built model that just literally takes up staff time where they could be spending it elsewhere. But also how how long does it take them to develop? How long does it take them, to enhance and trace down problems? That's all going to like use up staff's valuable time that they could, be enhancing the environment with or analyzing results. Like the more times people are spent dealing with that level of problem, the less insight you're getting into your results. Late submissions due to runtimes, that often has a very tangible impact, maybe in terms of fines or upset board holders or shareholders. And then the inability to reproduce results is just a key operational risk and impact. A badly managed system and environment will make it impossible to go back in time and produce a result which you had produced before. And if you can't explain why that's the case, how do you ever have any trust or faith in the results you've produced in the past? Technical debt, so these are more, technical costs. So inadequate data storage, like super basic version, just badly designed databases which take up way too much space or are very inefficient to use, either by the users or by the softwares querying the data. Bad data flows, non-standardized data flows, like in complex environments where you haven't thought to standardize your system, just how long and bad the flow of data can be. And then poor system integration. So just designing in a way that doesn't allow you to integrate from your various steps along that timeline, like of the actuarial system, or making it not possible to layer, like I mentioned, an orchestration tool on top of that. And then some strategic risks. So some obvious things like reputational damage, producing bad results, which need to be restated multiple times or are just outright incorrect. Failure to comply with standards like the CR because the models are incorrect. And key person dependencies. So in environments where the system hasn't been designed well, or you have one very technical person which built everything alone and in a way that isn't easy to hand over and that doesn't play well through the stages, you end up with only one person that can actually ever use that system. And that's probably one of the most common things you'll see. And I think something to add to strategic risk is just like, talking about the overtime, taking away the time people have to do the actual cool actuarial stuff, like the ad hoc investigations, experience investigations, like, putting together scenarios for new business deals. It's like, if those things take, like 10 times longer because your system is just not built well to do something ad hoc, just stealing away from the ability to have a thriving business and make real business happen. So we've got what we think are some principles of excellent actuarial systems. So some cornerstones, I think. There's probably so much more than this, but just from my experience, when I've seen these things or I've not seen these things, they really stand out to me in my ability to navigate and work in a system that I've never seen before, or how I can see like my ability to like trace and move through a system efficiently and use it like in a powerful way to do more than just its one purpose task, which is like maybe doing valuation, but the ability to manipulate that and trace and figure things out. So get into some of those things. So end-to-end traceability, this is probably a super rare one in most actuarial environments, and this for me comes in the form of logging. So automated logging, for example, in an SQL database, if you're dealing with valuation data and scripts, creating log tables which automatically populate, anytime anyone makes a change to that data. This also speaks to the ability to reproduce old results or explain why you can't. You should be able to, there should be logs of everything. Anytime anyone came into the environment and changed something, there should be a log entry which is automatically created for that little intervention which was done. there shouldn't be the ability to just go in and change something and it's not traced in any way. Modularity and extensibility. So just this principle in any of the steps, but it's going to be probably most apparent in your projection part, your like modeling sort of centerpiece, but just building things with a building block approach. So not repeating logic that doesn't need to be repeated, and building in a way that you can always, when you need to extend or change, you take the things you've already built, place them on top of each other, and then change just the one line you need now for this new product or feature that you've built in. Should never be having like full new copies of things, because then, anytime you need to change something, which is like a building block, you have to now remember how many places you have to go through and change it. And it's surprising how often you see that, but then how often you just have totally disjointed code. So data management, and this speaks to how do your relational databases work if you have a system where your databases need to relate to each other, but also managing backup procedures, like is it daily incremental, weekly full, and how do you do that through time? What's the lifespan of your valuation data specifically, or assumptions? And then also, how do you centralize those things? So in my view, like a appealing feature here is where everything is centralized. So I like an environment where assumptions, data, and output are all in the same place, which would be ideally an SQL database. And they should relate to each other. So you should easily be able to see almost like a policy that, left, went through a modeling software, got assumptions applied to it, and then came out in results and kind of like trace those all together, versus, like a CSV data and access assumptions database and I don't know, some proprietary results storage. Version control and auditability. So this is speaking to anywhere really where you've got code. So your modeling software, your scripts, your cleaning scripts in SQL, things like that. So using, I think, modern version control is severely underutilized. So things like Git. I think most people are using the, if any, version control, just kind of like copying their system forward each month, and not really having like a modern system with diffs. And the spin on this for actuaries that the computer science world really doesn't know is that, they're working with like just changes between their scripts, running their unit testing, and then signing that off, in a nutshell. But the actuarial spin on that is that we need to do an impact of results as well. So, we need to do that exact same thing that the computer science world does, or the developer world does, in terms of reviewing the code change itself, diffing it, and hopefully running unit testing. But also we need to do like full sort of impact result tests. So, like probably a Bell result, an EV result, or an SCR result, for each major change which gets done. And that requires like usually a specially built version control system, specifically for the actuarial system. And then performance optimization. So just thinking about time complexity when you do things. So it's so easy to, in modern softwares where it allows you to do a loop, for example, to forget about time complexity and just write the code you need to get the right answer or solve it, and forget that maybe you're creating like an exponential time complexity here, and your model's just gonna fall over as like every time you add more model points, it's just getting exponentially longer and longer to run. So things like avoiding nested loops and things which create exponential non-linear time complexity. So it's like if you haven't heard of time complexity, like look into it. It's a simple concept, and it's quite easy to identify when you like have that in your mind and you don't assume the computer is infinitely powerful. and then system integration. So whether you're building your own things or using some vendor stuff, which I'll speak about later, the ability to integrate with the various systems in the business and the various softwares that are at play. Like this allows you to build orchestration software, which I keep mentioning, but like if you can integrate into like your finance ledger environment and into, let's say, your FS17 tool, underwriting platforms like the pricing engine that the policyholder sees or the broker sees, like these things are powerful. So building with that mindset that this could fit into a greater system, and these things, there's no reason these things shouldn't be able to talk to each other immediately. So just like to take a step to zoom a bit into cash flow modeling systems. So, and this is really in the life actuarial space. And this is an area where we've got, I suppose, opinions, having worked with most of the major players out there or built even some of our own. We've got some ideas about what are like essential features or desirable features in your specific cash flow projection modeling software that I'd like to sort of share with you guys to keep in mind in terms of what makes something technically excellent to me. Is firstly to integrate well with other platforms. So this is just playing well with all the other softwares and not locking you in to your single environment. That's kind of like the Apple, it's like I prefer the Android version over the Apple version of this. Using modern frameworks, so softwares which use things like Python and VBA, which are well understood and are powerful, like at their back end, versus having built their own compiler inside, and the ability to do things like loops and classes. Like it's not something to take for granted, but the ability to actually like extend into those programmatic abilities like classes, it just creates so much power in the things you can make versus a software which is like a one-line approach, like a one line per variable type of thing, or just the logic flow. That for me is quite powerful, and it also allows you to sort of maybe be able to debug and understand better, which is something to speak about later. Parallel processing, or really just the ability to scale well with your computer power. So, any software you use, whether you built it yourself or a vendor, it should get faster as your computer is stronger and be cloud ready. So like go all the way to cloud computing and allow you to like when you switch on resources, it scales linearly with the resources that you throw at it. Text-based code. This one's probably rare and not obvious, but this speaks to the ability to do good modern version control. So for me, get compatible. So text-based code, meaning even if you're in a third-party or proprietary vendor, the underlying code files are text-based and human readable, and the code and formula are in there, so that when you do version control, you can diff those files without being now in the software. You can like look at them externally and see the code changes which have been made. And what is often the case, which is not desirable to me, is where the underlying files are encrypted or obfuscated so that you can't do that, or it's meaningless to do that. And you can still have a Git version control system, but your ability to like diff things just is so much harder. And even besides Git, like underlying text-based code, just it's powerful. It allows you to like migrate well, or like automate code changes and things like that without, you can interact with your code without going through the interface of the vendor. Like that's a plus for me. And some practical things here is fair pricing, so cost-effective licensing for all team sizes. So here, what I usually see is like user-named licenses, which I find not desirable, versus concurrent user licenses. Like is I would always favor a situation where it's a concurrent user license system or a single, obviously that'd be great. You buy once and it doesn't matter how many users, but concurrent user over named user, because named user, it's expensive and it's also just so difficult to work with. Familiar languages. So this kind of speaks to the syntax within the software, or if you're building your own thing, don't use something new, crazy and shiny, and go for things like Python or even Java, things which you can easily Google, and there's this abundance of stuff on Stack Overflow. Or if you're using, something off, like a vendor solution off the shelf, like their syntax being something like VBA, which is easy to understand for most people. And also, just maybe the software itself being familiar, and that speaks to sort of having resources available in the market versus something which is maybe custom built by a smaller, unknown brand. That can be difficult. Not to say it won't be good, but it can make that harder. Detailed documentation, also not something to just assume will be there. Big proper vendors, but having really bad help files just makes it impossible for you to a new user to onboard themselves, for example. So a really detailed help file is something to check when you're buying a software. Don't take for granted that the help file will be any good. And it just, if you've got a good help file, you can usually help yourself. If you've got a good enough technical person, they could probably even teach themselves from scratch how to use a software. But if you don't have a help file, it's just it can really make things difficult. And then also your aftercare and follow-up support, does your vendor have good support, or is there some a well-known software out there that you can Google? And then access control, maybe also not thought about enough, but being able to separate your runners from your developers, because it's often that you want to separate your systems team, or I believe in that. So, really have your system-minded people and not really have your day-to-day users and runners of the system also being able to make changes in the code, because they're not really geared to think that way, and how they might inadvertently be changing and affecting things. So being able to separate that somehow, having a power user and an admin that can set who's a developer, who's a runner. So having thought about some of those desirable features, maybe some short advice on how do you evaluate which is the right system for your business, because it's not there's one greatest system that I can recommend. It really depends on the size of your business and what you guys are doing, what you're building, and where you're going. You wouldn't recommend I don't know, maybe this crazy C++ solution to what is just a startup that needs a prototype. So the first thing I would assess is the learning curve of the software versus the availability of skilled resources, and how big of a team do you plan to have yourself? Do you want a lightweight team of one person? And do you foresee that team having a high turnover rate? Is it senior? Is it junior? This is gonna sort of affect how much of a learning curve of the software you should be able to tolerate. So a more lightweight team plan means you probably want something which is really easy learning curve, quick to develop, quick to learn, but maybe it's gonna be a little bit weaker elsewhere. Features versus price. So also size of your business, and you would need to do a cost benefit analysis here, but often the way these softwares work is not all of them, but that you have your standard version, and then you pay extra for the extra cool things you want, like GPU programming, an AI tool or assistant, cloud programming, and you would need to go through those steps and actually see are you going to get that cost benefit, or how much it's going to cost. Do you need GPU programming? How big is your book? how much time is it going to actually save you, and try to put a number on that. Yeah, do that features versus price, and I don't know, try to go for these guys that are going to try and sell you every single like little thing at an extra price. Ease of implementation. So I kind of always refer back to this idea of Python versus C++. Like if you want to build something really quickly, which works, you would go for Python. If you need to prototype something in a week, you're going to go for Python. But if you need something which is like of the utmost efficiency, but you can take 6 months to develop that, or you've got a team of engineers, you're going to choose C++. Neither of them is wrong, but it depends on the context. So same for these softwares. They are lightweight, easy to develop in softwares, which are lighter on all things like help file or efficiency, things like that, but they are quick to develop in, and they're easy to understand. And then there's your more robust, like heavy hitters, which it's like you're a very big established insurer, and you've got a very complex and large environment, and then you want something which is enterprise ready and which is going to actually take a little bit longer to learn and implement in, but at the end it's going to be something which is like solid versus something lightweight and for like a new venture. And then integration capability. So you would want to assess how much integration do you need. So how many softwares are in your tech stack, and how many systems do you need this thing to integrate with? So if you are, once again, one of these bigger systems and bigger companies, and you've got like all these softwares under your belt already, and you're doing F17 here and your finance is done here, you want something that integrates well. Whereas like if you're building this thing from scratch, it's like brand new, you haven't got anything yet, you're up and coming, you might accept something which doesn't integrate that well because you'll just build everything in this tool. And sort of having gone through this a little bit, just I don't know, our view on the systems modernization journey. So this is either starting from scratch or moving maybe from something which is legacy to some of the steps along the way that are either obvious or not. But the first thing is a business case, because it takes time and it has a direct cost in terms of licensing and in terms of manpower, whether it's internal or consultancies, and it requires a business case to be developed and for vendor trials to be done against that business case. That can be taken to key decision makers and boiled down in a way that like they can approve or not. That's kind of forgotten. Is like if you're in the team and you want to do this, there needs to be a business case, and there are people that are very good at helping you do that and get these things over the line. Procurement needs to happen once trials are done and RFP processes being followed, and like your various providers have been evaluated. That's usually key, is like you've got your list of things after you've done what we spoke about on the previous slide, and you assess what are the things that you need. You would then procure your software at the end of your decision. You would now embark on your implementation journey, and hopefully keep to the timelines you put forward in your business case. And then you hopefully get to a place where you are running on your new software and you enter the actuarial and systems control cycle. And it's no easy feat. And I'll hand over to Anne to close us off.
Thanks, Garrett. So what we've tried to convey in this presentation is that the intersection between traditional actuarial science and all the the strong problem-solving skills we have, and the IT world and the best practice and good systems thinking that comes from there, that intersection is what defines, in our view, the systems actuary. Hopefully you'll see the value of a systems actuary in your team. And as with all things in insurance, the degree to which you might need this skill depends on the specifics of your own business. But we hope that we've convinced you to at least take on some formal systems training or procure the services of a systems actuary. In the meantime, we hope we've given you some good tips on what to look for in excellent actuarial systems and how to choose the best cash flow modeling system for you. So thank you so much for attending our session today, and we look forward to interacting in the Q&A.
Thank you.